Hi everyone. Uh, Starting a series of video on me working on this command line interface app. I'm building this because actually my goal is writing a datetime handling library for purescript, which there are none right now, and it's a little shame. Right now, when I have to do that, I'm using FFI, so I have to import some kind of JavaScript library, for example, Moment or Luxon, and wrap their functions to use them on PureScript. So I guess it would be cool to have a native PureScript solution for that. The problem is that to do that, I need some kind of database that will help me translate time. With daylight savings, with all kind of time zones, which change all the time. So it's a bit of a mess. Luckily, there's a database which is called tzdb. This is the link. Uh, okay, we can download it. Okay, as you can see, it's in this weird format. Basically, there is a set of rules that define the daylight saving rules. So, for example, in this rule called EU Asia started from 1981, and I guess it never ends. And it says that in the last Sunday of March at 1 a.m., I don't remember I think this is UTC time, there's a 1 hour save for daylight. And then we have these zones, which define a zone. It says what's the rules that are applied to that zone, I guess. It's a bit of a weird format, and it doesn't look like it's incredibly well documented. For example, the guy that it was using, there was no mention of this max string here. So we'll see what we can do. tzdb GitHub. I have to add that I probably will, there's no need to build this. Maybe there are some solutions that already exist. It's just something that I wanted to do as an exercise to try things, I guess. So I'm pretty sure there's supposed to be link to documentation of this database somewhere. Okay, maybe here. Yeah. The database. Oh, it's the commentary. How to read database source files. Cool. So let me just search for max. Yeah, it's here, but it's not explained. I guess I have no idea, because there are, for example, here there are two rules that start bottom 2007 to max. So I'm assuming that like never ending. Okay, yeah, well, it makes sense. It's the start of daylight timing, daylight savings, and yeah, the daylight saving. Okay, cool. So we'll need to encode these max somehow. Okay, I already started working on this project. But we'll go through what I already done to see how this project is structured. So this will be a command line interface. So obviously we'll have two tasks approach. The first one is building a library that's able to parse these tzdb files and create the relative JSON, because I want to encode these files in JSON. And the other part is building the actual command line interface program that will take as a parameter the file to read, and will the output path, and will build the JSON file. So right now I'm only working on the library. Why is this empty? There's something weird happening. Let's just open this file. Okay. So these are library right now. The module name is a little weird, but maybe we'll change it sometimes in the future. So right now I'm using megaparsec because I wanted to try it. I don't have much experience with parsers. And I already defined a few data types that we'll be using. So right now I'm focusing on parsing these rules. And this is how the rules are structured. They have a name, they have a starting year and an ending year. The ending year can actually be a number or only when the ending year is the same as the starting one, or a max if there is no limit. Then there's this type which is actually not used, so we can ignore it. In is a month. It's the 3 letters representation of the month in English. On is a little weird because it's basically it's the day on which this rule is starting. It can be a number, it can be something like last Sunday. I'm gonna assume that there can be a first too. I never saw it, but just to be safe. And then there's the 3-letter representation of the day. And then it can be a Sunday, which is the first or after the first of the month, or it could be a minus equal day. Then we have an at that represents the time at which this rule starts, which can have an extra letter that represents various time zones. So it could be UTC, GMT, could be a standard time, which means not the wall clock, but the standard time on the clock without the daylight savings. There's the amount of time that's saved. And then there's a letter, which basically is a letter that's used to replace the usual time zone format. So for example, if the Central European time could be SET or SEST for the standard time, for the summer time. And so this is a letter that gets added or replaced in case. Okay, so we are gonna model this on a single rule as a data type that we call the rule. And this is a record in Haskell, which has this field. So we have the names, which is a text, which is just a type of string. This is a very confusing aspect, which when I was starting using Haskell made me waste a lot of time. It's probably the same for everyone because there are a few string implementations. So text, string, byte, a lot of different byte strings. I feel like text is always the correct one to use. And something that you really want to have is the overloaded strings extension, which allows you to do stuff like this will be automatically text. Without that extension, you'd have to do something like pack, which converts a string to text, which is a little annoying. So our data type will have a name, which is the rule name, a from here, which you will parse as a number, a to here, which I initially encoded as an int number. But that's not the case because we can have a max label here, which means that there's no max here. So I feel like we can encode this probably as a maybe int with nothing, int there's no end here yet, I guess. Maybe the US will add a new rule, so it will become from 2007 to another year. There is a month which I'm already encoding with a number value, start from 1 to 12. Not sure if this is the best correct implementation, but I'm using this for myself, so I'm just gonna do what's best for me. I think will be best for me. Then there's the day, which right now is just text, but we'll find some way to encode this correctly. Then we have the at, which I'm encoding as this data type, which is just the time in minutes after midnight. So this is 2 a.m. It's going to be under 20 minutes. And then we have the suffix, which is the letter, which could be W, which is the wall clock, and it's the letter that's used when the letter is omitted. Then we have standard, which is non-daylight, GMT, UTC, or Zulu. We'll see how this stuff is handled later on. I'm deriving a few classes, so there's a queue, which means that I can compare rules with each other, show to print them, and then generic, which is I'm just using to derive the to JSON, so that I have a JSON representation for free. Encoding, in this case, just encoding, because I'm really worried about encoding these data types. Okay, I guess we don't need this actually. I also wrote a simple test, which is not actually a test, but it's just trying to parsing and printing stuff. We can improve it, make it a real test. So right now I'm getting an error because I changed this to here from an int to a maybe int. Let's try to fix this. So we have our rule parser here, which is a megaparsec parser. It feels pretty simple to use. Not gonna explain it because I probably do a bad job, and I think megaparsec documentation is pretty good. And maybe we'll go over things while we work on this project. But trying to be very quick. These are all the operations that are done by the parser. So it starts by matching a rule string, which we discard. Then we have one or more spaces. I'm going to explain this operator very quickly afterwards. And then we are parsing some alphanumeric chars, which is the rule name. And we pack it. Pack is a method inside of the text library, which means it takes a string because this parser, let's open stackage. Let's go to the alpha num char parser. Okay. This alpha num char has a kind of complex signature, which is, if you're not very used to Haskell, can be a little weird. It's basically saying that inside of a monad M, it returns a token S. And in this case, the token S is a char. I'm using sum. Let's see if we can find it here. No, it's not here. Sorry. Well, anyways, sum is an operator that takes a parser that can parse one thing and transform it into a parser that parses a list of that thing. So we are parsing a char with sum. It seems it parses from one char. Instead of parsing just a single char, it becomes a parser that parses a list of chars. A list of chars in Haskell is a string. We have defined our name as text. So we need to transform string into text. And that's why we pack it. And here we're using map because this is inside of a monad. So we're going to go inside of that monad. I'm gonna make a very bad job of explaining this stuff. But basically, some alpha num char, we can say that it's basically a list of chars inside of a monad. We want to apply the pack operation to this value inside of the monad, and so we use the map operator. I'm not sure if it's clear, but I don't want to waste time doing a poor job explaining functors and monads. Anyways, we're converting this to text. And here we are using this applicative operator, which basically says discard anything that the result of this and just take the result of this other one. And so we are skipping some spaces basically. We are reading some alpha num char and we are converting to text and we're saving into this name variable. We're doing something similar from the from here, so we're reading a decimal number after skipping some spaces. And then we have the to here, which is the culprit that's causing our error. So we're skipping some spaces and then we are using this p2 here parser that we define up here. So this parser takes a default value, which is the from here, and returns an int parser. Why we use this default from here? Because we try to parse a number. If there's no number, I was assuming that the only option was the string only, which in that case I would have returned the default value. But then we also know that we have a max string, which means that there's no ending. We are using two new operators here. So there's try, and there's this, which is the alternative. This one means try doing this operation. If it fails, do this other one, which kind of worked so far, because so far our only two options were either only or the number. But now we know that there is a max. So we have a third option. Here try is used because if without try, this decimal will try parsing the string, will fail, but it will already have consumed part of the input. By using try, the part of the input that was consumed by decimal is rolled back and then this one can try parsing the whole string again. So you have to do a couple of operations here. So first of all, we need to add a third possibility, which is max. So when we have a string max, we can discard it. And what we want to do is return nothing, meaning that there's no end here. Obviously, this is not good enough. Let's try saving. It's not picking up my default extensions. That sucks. What we can do is do stack test file watch. I will use this to get our errors. Okay, so now it says that we can match type maybe a 0 with type int, because obviously this is an int parser of ints. This is a parser of ints, this is a parser of ints, and this is a parser of maybe something. So you can even infer that it's maybe int. So the first thing we can do is change this one. And we're getting a different error now. So what we want to do is transform this decimal part, this int parser, in a just maybe int parser. So we know that here means that it parses an int, so we can just map a just inside of it. And here we can do this. So pure is a way to wrap value inside of, in this case, our parser monad. So we can just put a just here. So we're wrapping just from here. So now we are returning here a parser that parses maybe ints. Here we return a maybe int pure value. And here we return a nothing pure value. So if we save, hopefully we don't get an error anymore. Okay, let's see. Ambiguous value S0 arising from the literal only. Okay. Oh, where are we getting this error? We didn't have this error before. Oh, yeah, of course. We can use this operator because it messes up the associativity and the precedence. Okay. Now it complains that we're not exporting some function. So let's do this or now. We don't care about that. Okay, success. Now what I want to do now is add this back so that we can parse max2. Okay, something I want to do is that I'm using a newer version of Stack, and I get some warnings complaining that I'm not using deriving strategies. Do you want stock, new type, or any class? use deriving strategy to specify a strategy. So let's check if I have, let's do deriving strategies. And then let's check Haskell deriving strategies. I don't remember the syntax. We can fine-tune which instances should be derived with particular deriving strategies. I don't feel like this is that important for me because I'm using pretty standard stuff, but I just wanted to remove the warning. So let's try with any class, because I think I can't use stock with to JSON. Okay, scratch that. Let's do this. Oh, okay. I don't get the warning anymore. Cool. Now let's fix our tests. You want them as actual tests. So right now I have this set of rules with some extra text, this set of zones. Is it supposed to be strings? Let's see. No, of course it parses text. Okay. So I think I have an oldish version of stylish Haskell installed here because if I remember correctly, it's the one that gives issues with default extensions. It doesn't pick them up. Okay. I have this here. Let's check this stylish Haskell version 0.11.0. No, it's the latest version. Was it HLint maybe? Let's try this. Stylish Haskell source tz. Yeah, this one works. HLint source. Oh no, I remember now. I remember it's a fly check issue actually. And I think it's this one. I don't remember the syntax for this. What I can do is go check my other config. Yeah. Add hook ask hook fly check scale setup. Okay. And then in packages. Okay. Should be good enough. Oops. Now let's do a Doom reload. Oh, come on. Ah, let's try starting it. Suspicious state. Now it actually works now. So let's try doing something like this. Do we get errors? No, it's not working. Oh, it's so annoying. Sorry, this is a newish virtual machine. You don't have time to say that properly. Well, so let's try using hspec to ensure there's a very nice guide. Okay. So let's import test hspec. And let's create some tests. So describe rules. And we can do it parses a series of rules. And then we can do parse test many p rules, and then we can do something like can check the length. So let's do like length rules. Yeah, let's say it's different name here. Length rules should be how many rules do we have? 1, 2, 3. Oh, let's put a number. Should yell at us telling the correct number, and then we can replace it. Is it using tabs here? Why? So there's no hspec module installed. Let's do this. Let's go to the Gabber file. Hspec. Is it? Yeah. Okay. Oh, I suppose this parse test is not what we want to use. Let's check. Pairs test. Yeah, it runs the parser and prints. Even if it's not megaparsecs once, it's okay. So we don't want parse test, we want to return the result of our parser. I think complaints about this one. We can probably. I don't think we're benchmarking. Doing benchmarks, benchmarking this library. So we can comment that if it helps. Okay, so instead, oh come on. Let's try. So we have a few options. We have parse, it returns an either errors. We have run parser. What's the difference? I wonder what the difference between parse and run parser. String as either parser bundle as EA, and the signature is exactly the same. Oh, okay. So okay, let's use parse. And obviously now this could be errors or could be our length. So maybe what we can do. It's probably not very pretty. Let's see if it works though. Okay, we got an error. Couldn't match type text with char. Our rules. Because parse expects a string now. Okay. Oh wait, that's why, because it like name of source file. What's the source file for? I don't have a source file. Okay, I'm a little confused by this. Parse p file input runs parser p over identity. Returns. Okay. Parse numbers. So I have to pass it the file even if there is none. Okay. So the parser, the file. Okay, we're doing a mess here, so let's just do this for now. So what if return rules should complain telling us what's in here. So it's either an error or an array of rules. Okay, that's what we were expecting. We should have a few operators that will let us check that, maybe not. Runner. Let's see, hspec check write. Check if right. It's a very poor choice of words. Also because I'm searching on DuckDuckGo, which never returns any useful results for me. I don't know. Okay, we're back to where we were before. Oh, there's actually an hspec megaparsec. Oh, that's pretty nice. So let's not reinvent the wheel. Let's add hspec megaparsec here. And then we can do a parse many p rules. We don't really want to do should parse because I don't want to match all these rules. I don't care that much. Okay, we can use this. Parse satisfies. Yeah, we're doing the same thing we wanted to do. So equal 10. So we want to say that we have 10 rules as a result of our parsing. We get an error. Why do we get an error? Because, oops, I did a bit of a mess. So I was here, parse satisfies 10 length. Not sure why. It's parse satisfies. And also we should import test hspec megaparsec. Okay, we did it. Obviously we get an error because the length doesn't match. Doesn't give us the correct value. I wanted to cheat. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 18, 19, 20. Should be 22. Okay, good. Good. Okay, now we want to parse a few values. Let's check if our 2-year works correctly. So what I guess we can do is grab 3 rules from here. Okay, so let's do this. Rule 1, oops. Rule 2. And rule 3. Oh god, I hate this keyboard. Okay, let's add type signature so it doesn't complain with warnings. Okay, and we can use these for our tests. So we can do here only is fine. Here we can put 23. Sorry, and here we can use max. Okay, and then we can say it parses only and year. Okay, let's see how we can do this. So we have parse p rule 1. We can use this one. Rule 1 parse satisfies. Oh no. Okay, sorry. And then we have a match with a rule. I'm gonna explain this syntax in a while if it works. And then we can say, let's open our file, data definition. Where is it? Here. The 2-year equals just 1921. Okay, we get an error because we have a tab instead of a space here, which you didn't account for. It could happen that these are tabs and not spaces, so maybe we should fix this bug. Okay. While loads, I'm gonna try starting Emacs because I feel like it will work now. Yeah, it works. See that this one is redundant. I wonder why. Oh, because those operators are imported from megaparsec. Oh, really? Okay. Do we have a tab? Parse Unicode space character and the control characters tab, new line. Um, it's supposed to parse tabs. Is space. Okay, this is pretty weird. It says only white space characters here, so let's try something very quickly and see what happens. So instead of this, let's do many or some space char. Lexical error in string character, literal character T. Megaparsec lexical error string. I feel like I'm looking at the wrong thing. Yeah. The problem is that there is a tab inside of this kind of string, which is not allowed. I'm not allowed to do. I mean, it works here. We're not testing that here. Why do I have all these tabs? What's happening? Let's do this. Tabify. The data constructor rule is not in scope. Isn't it? I'm importing tzdb JSON. Oh, we're not exporting it from here. Okay, sorry. Just need to do something in a couple of minutes. Okay. It works. Okay, so now we can try the other two rules. It parses an ending here. I feel like we can define our own parse, which is going to be parse because I'm lazy. Rule 2, parse satisfies. So what's doing here, this is allowed by the extension record wildcards. It means that it's unpacking the fields of rule. So we go back here, we can see that rule is a record as all these fields. And we can access the fields directly. So now we can say to year, and this is equivalent to do something like R to year R equal just 1923. I feel like in this case it's not much better because we're all accessing one field, so it's not that of an improvement. But anyways, for consistency, we're going to change this to this. Okay, and then I want to change it. Check test this parses missing ending year. Do parse p rule 3. Parse satisfies. Every single time. Rule to year equals nothing. Yep. Okay. So this is good. I don't really want to test the name. The month, it's very trivial. We should test this maybe. So let's try this. Let's try this. I don't want to test the letter, it's very trivial. I don't want to test this neither. So it parses add without letter. So let's do parse p rule, rule 1. You know what? Yeah, let's use different tests. Satisfies, and then we are rule at equals at it's 23 times 60 because it's time minutes, and then we have the letter W for wall clock, and then it parses at letter parse p rule 2 parse satisfies at equals at 23 times 60 S. We get an error because we're not exporting at. This means that we're exporting both the data type and the data constructors. In this case, it's just one per type. Okay, works. It complains here because R is used by the quasi-quoter in there, which the thing that here that allows us to put a block of text without caring about anything. So I'm gonna change the variable name. So what we want to do now is to encode no, this is done. We want to encode the date. Should we call it day? Feel like it's a bad idea because day is already used, but probably gonna move all these in its own module. That's gonna be not gonna be exported. Well, I mean, no one is gonna use this as a library, but anyways, module tzdb JSON types exports rule at where tzdb JSON types hs. Yes. We can move all this stuff here. Let's do this, 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 and this. This can stay here. Just a type synonym. We can move this here. And we can import tzdb JSON types here. Spec. Import tzdb JSON types. Import ghg generics, which we don't need here anymore. I'm using deriving strategies, come on. Oh, anyways. We need to encode this day. This could be a number, a day string. So for example, mon to could be last plus day string. So for example, last sun could be a, I don't know, but let's assume it could be a first day string. There could be a sun major equal number. It could be a sun minor equal number, if I'm not wrong. Let's close this, let's close this. Let's close this. Yeah. So the problem is that we could do this with a sum type. So something like, for example, day number int or something else or something else. The problem is that we want to encode this to JSON, and some types are not really that nice to encode in JSON, especially if you have to work with different languages. So I feel like we'll use a record for these two. Yeah, this is probably not the best. Maybe we can improve it later on, depending on how we're going to use it. So we're going to encode a number. We're going to encode a weekday, which is a maybe. This one is a maybe. Kind of sucks. An operator. This kind of sucks because we have three maybes. Can be a lot of combinations because we can have a single number. We can have a number with a weekday. We can have a weekday with an operator, or we can have just a weekday. So no, that we're not going to do this. Uh, Currently think of a better solution. Well, let's leave with this for now. Running out of time, so I think we'll try to do this. Okay. Okay, now we want to change this here. I want to export this. You want to export the operator too. Then you want to go to the library. Okay. And then we need a parse day, which is a parser of days. Okay. So we have a few options. We can probably try this. Can be a number. So it means that we got the number, returns a day, number, sorry, just number, nothing, nothing. So just say number, weekday, operator. Okay. Okay, let's see if this works. Okay, these rules all have a numeric day, so we can try it. Parses numeric day. So parse p rule 1, parse satisfies rule, and then we can say day equals day just 14, nothing, nothing. Get an error. Unexpected S. What? Oh. Oh, of course, it broke all these other tests. Let's comment this for now. Okay. Another thing that you can parse, it's just a weekday. Which you want to encode as a number. So we can do a parse p weekday. So what we're saying here is that it's a choice, it can be any of these values. And if it matches the strings Monday, returns 1. If it matches string Tuesday, returns 2. Wednesday 3, of course, and so on. This is very similar to the other operator we used before, like this one. Except this one is in a functor context and the other one was in the applicative context. Okay. You might want to add some documentation to it afterwards. I know it's someone starts Sunday as the first day. I don't really like it. Okay, so now here we have, we can do this, and they just, sorry, nothing, just an, nothing, p weekday. And then this can become try p num or p week. And then we can probably change this here, change this in sun. And then let's do this. Parses a week, day, parses rule 2, and this is nothing here, just 7. Okay, it works. So now I really have to go. But anyways, next time we'll implement these other combinations, and then we'll see if we can refactor this into a nicer parser. Then we re-enable again all the rules here, and we'll see if everything works correctly. And then we'll move to zone parsing, which I will have to see how it works, because there's like an introductory line, and then all the other lines are defined by an indentation. So we can define some kind of way to, with parsec, to define a group of lines defined by the first line. I don't know how to do it. It's possible for sure, I hope. And then we'll parse zones. And then once we've done that, we'll check the JSON output, and we work on the command line interface side, which is gonna use opt-parse applicative. I rushed through a lot of things, I'm sorry. It's really my first times doing videos. English is not my native language either, so can absolutely be much better, and hope it will improve with time. Thank you for listening.